The arc length, well, let's refer back to what we did yesterday. When we had what we called arc measure, the measure of an arc was always equal to what?
The angle.
The measure of the angle, right. The measure of the arc always measured the measure of the central angle. What we're going to do today is talk about something called arc length. And the arc length will not equal the angle, okay? It's not going to equal the angle. So what I want you to kind of see here is notice when you write out arc, the measure of an arc, see how we usually put that, we put a curve over it? And then inside the central angle symbol, there's also that little curve. Try to remember that. It's kind of the dumbest thing that I can think of as far as how to put two and two together. But if you set it up that way, it might not be a bad idea. It kind of helps relay the two symbols that way. Arc length is totally different. Arc length winds up being the distance that's on the circle. Okay, the arc length is going to be, excuse me, the distance at all. So if you think about it, you have problems with that?
Yeah, I know. I keep breaking.
When you start thinking about arc length is a portion of your perimeter. But in terms of a circle, what do you call the perimeter? The circumference. Okay. So what we're looking at here is it's going to be the distance that you walk on a circle. Now, if you think about it just in terms of distances, when you have a circle, we know that the shortest distance between 2 points is always a straight line, right? Mm-hmm. So if you're walking part of the curve, is that longer or shorter? It has to be longer. Okay. It's a longer distance to walk around a curve as opposed to a straight line across. Now, what we worry about here is that there's kind of a funky formula to set this stuff up, but it all stems from knowing what circumference is. Okay. Now, I think we defined that yesterday, didn't we? We called it the distance around the circle. And if I'm not mistaken, we also had a formula for it, right?
Yeah,
It's circumference equals pi.
Or you can double pi. Yeah, you can double pi.
So it's 2 pi r or pi times the diameter. These are the types of problems that we're going to leave in what are called exact form. Okay? We're going to write these things out in what are called exact answers. Very similarly to what we did with square roots. Remember what we did 30, 60, 90s, 45, 45, 90s, and you had a 45, 45, 90, you had side lengths of 4. It was 4, 4, then it was 4 root 2. We didn't use decimals. We left in what we called exact answer. We're going to do the exact same thing here. Anytime that you have pi, we want to leave our answers in terms of pi. And it's a matter of basically doing all the regular calculations like you would normally, and at the end putting pi in your answer. If you press buttons on the calculator, for those of you guys that have the multi-view, if it's the pi value will continue with it, just like we did with the radicals. If you multiplied 3 times the square root of 5, it would say 3 root 5. If you say 3 times 2 times pi, it'll spit out 6 pi. It'll leave its answer in what we call that exact form, which is good. There will be times that we have to manipulate it a little bit, but it's not going to be anything crazy. Speaking of pi, I wrote up on the backboard some of what I'm going to call our rules for the pi down. So we're going to do this per class. And that way you're not competing against anybody else in any of the other classes. If you can write down 20 digits of pi, you get 2 points. For every 15 digits after that, it's another point. So if you do 35, it's 3 points. 50 is 4 points, and so on and so on. So as you get into the winner of this class period, will get a bonus of 5. Second place is 3. Third place would be 2. Yes, ma'am?
You gotta memorize it.
Yeah, I would prefer that you write it down because it's going to be easier to be able to verify it. You know, that way, and plus we can all do it at the same time. You know what I mean? Yes, sir.
What happens if like people tie for a place?
Sorry, it's a terrible cough, isn't it? You've had it for like almost as long as I had it for. If 2 people wind up getting like 60 digits and they win, I'll give them both 5. I'm not going to make you split it. Unless there's like 7 of you, then I might do flip a coin or pick a number.
5.
Or we can just fight in a circle.
Yes.
With some rock music.
The bonus points I'm going to put on your quiz category, so it's weighted like a homework and a half. Yes, sir.
I've heard of competitions like professional ones. They start after 3.14.
I'm not going to count the 3. It's
After the decimal.
after the decimal. Okay. So 14159 and so on and so on. Now, if you really start to think about it, 20 digits is 2 phone numbers. 20 digits is just 2 phone numbers. 815-754-2100. Hey, there's the school's phone number. That's 10 digits. You know what I mean? As you start going through like that, if you memorize the digits, guys, if you memorize the digits as you would a 10-digit phone number, area code, 3-digit, 4-digit, you should be all right. You should be able to knock out 4 or 5 phone numbers without a problem. Okay? What? You don't know 5 phone numbers?
I forgot my mom.
8675309.
You made that joke yesterday.
Boo.
Bye.
Don't come back.
Thank goodness.
Look, he
I think he's waiting for you to say
You can walk out.
We're being for real.
I'm leaving.
Wow, that's great.
Goodbye.
We're good. Hey, is there anything good to sell while he's gone? You may want an eBay account.
His laptop.
I'm leaving.
Okay, bye.
Hey, bye.
Not gonna be
Who cares?
No one cares.
So if your radius is 4, what's your circumference?
Radius squared.
It's yeah.
What's the formula for circumference again?
8
pi. Very good. So if your radius is 4, it's 2, 4, and a pi, so it's 8 pi. Real fast, people. Actually, first I didn't ask this, which I was kind of surprised by, but it's normally a question that comes up pretty often. Is where pi goes in the formula? As you see, as I wrote it as this, I put the r value at the end. But then when I put it together, it was 2 times 4 times pi. The reason why the r value and the pi value switches spots with each other is that the order in which that you write stuff down, you always start with numbers, and then symbols, and then variables at the end. So that's why we went with 2 pi, then an r. But then when you put it together, it's 2 times 4 times pi, and then your answer is just the 8 pi. It's just the magical way that we do things, if that makes any sense. So you'll see it float around back and forth. Okay? And quite honestly, you can put in your calculator 2 times pi times 4, and it'll spit out 8 pi. All right. Now, this idea here between the difference between what we call arc measure. So if this is 110 degrees, and we have a radius of 4, I would say that, let's see, this is AB. If this is the measure of AB, the measure of AB is always going to be what?
Big 180. And the measure of AB. Oh, 1,000.
Yeah. It's 110 because it's the measure of the central angle. The central angle here is 110. Now when we do this, we're going to write it out as what's called arc length. You're going to see it written a couple of different ways. You will see it written as arc length AB. It might say length AB, and sometimes it might just say, bless you. It might just say AB. Remember, in this type of situation, it's usually going to say arc length or length. Very rarely will it just say AB, but I have seen it from time to time on like just weird worksheets. But this whole idea of arc length is it's a portion of the circumference. So there's a formula in order for us to make this work. Arc length is always going to equal your central angle over 360 times your circumference of 2 pi r. And what happens with this idea of arc length is that there are 3 different ways to write it out. There's going to be 3 ways to write out the formula for arc length. So again, arc length is always going to equal central angle over 360 times 2 pi r. What does 2 pi r stand for? It stands for the radius, right? I'm sorry, it stands for the circumference. 2 pi r is your circumference. What's 2 times r?
Your diameter.
Diameter. So depending upon what information you have, you can write this out 3 different ways. So all 3 of those, guys, all 3 of those mean the exact same thing, except the fact that you're changing what 2 pi r stands for. 2 pi r is either 2 pi r, 2r is your diameter, so it's pi times your diameter, or 2 pi r means the same thing as circumference. So you can write it 3 different ways, and there will be times that you need to know which one to use, because you might have to work backwards. And you'll find out also that this turns into like 1-step algebra, really, or
So
it's
would the
better.
better one be like if you didn't have the radius?
Yeah, and I've got an example of all these things here in a little bit, because depending upon what you know, you can solve for other parts. So if you think about it, arc length is an unknown, an angle can be unknown, and your radius can be unknown. So depending upon what you are given, you could have 2 of those 3 things, find the third. And no matter what, if it is 2 of those 3, it works out being a 1-step equation, just a matter of substituting it in. Yes, sir? It is the same. It's the same. It's the same, but a lot of times in the diagrams, it might just say radius and formula. So you still have to double it anyway. So that way, by writing it out, you know what you get. That's all. But you're right. All right. Actually, this is also, just so you guys are aware of, that right there is how you would simplify what's it called an angle measure, or no, sorry, angle degree, into what's called radian value. Radian value is that button on your calculator that says rad, the one I tell you not to use, because it deals with it in terms of angles in terms of pi, portions of the unit circle. This is stuff that you'll do next year, but it comes from this, because what's 2 over 360? It's 1 over 180. So you're able to convert stuff later on. So just so you know, you will see this again next year. Okay. So going back to what I have here, if I wanted to figure out the arc length then of that AB, yes sir. What do I do?
You put it in the calculator.
So we take our central angle.
110 over 360 times, I did 2 times 4 pi.
Now, you can do one of 2 things. You can type that exactly the way you see it in your calculator. If you don't have the a multi-view, you would just type it all straight through, get whatever fraction it is, and then put pi in your answer. If you have the multi-view, you can press the pi button and it will continue it through. I believe it's second division, I want to say. Is that right? Is it division?
Yeah.
Otherwise, if you don't, if you don't, you can always simplify your fraction. Zeros drop. 4 goes into 36 9 times. 11 times 2 is 22. Slap a pi next to it, over 9. And there's your answer. It'll do the exact same thing. Okay? What's that?
I got 11.
Did you forget to multiply by 2?
Yeah,
I got 22 pi over 9.
well,
I got 22 pi over
It
9.
should be 22 pi over 9.
after
Okay.
that.
Make sure you write it out. Guys, make sure you write out formulas, fill in the blanks as you're going through it. It's the best way to do it. That way you don't mess something up. Okay? So the distance on the circle is what we would call 22 pi over 9. Yes, sir?
Will pi always be on the numerator or
What happens is that this is the same thing as saying 22 over 9 times pi. The proper way to write that is 22 pi over 9. And the reason that we write it as 22 pi over 9 is because of what you'll do next year. Again, as you get into what's called the unit circle, as you start talking about that idea of what we call radian measure, a 60-degree angle has a radian measure of pi over 3. Well, if it moves over here, it's got a measure of 2 pi over 3. So it just kind of works itself around. That's just how we write it. We don't write it as 2/3 pi, we just write it as 2 pi over 3. It's just the common, it's more of the math etiquette way of writing it. It's not wrong if you wrote 22 over 9 times pi. Just as long as the pi doesn't sink. Let it wear its flotation device. Don't let it drown. Sometimes. What's that? Yeah, don't let the pie drown. Soggy pie is bad pie. I was thinking, like, I really feel like I should laugh at him just to make him feel better. And then she's saying, I'm not going to do that because he's an idiot.
Mr. Murphy, what's your favorite pie?
I don't know.
I like coconut cream.
I don't like pie.
I like West.
Let's try this one. I'm not that much of a dessert person. Yeah, I'll have a piece of cake or I'll have a piece of pie. I think I like apple pie. I'm not a fan of anything pumpkin. Pumpkin stuff just tastes gross. Yeah.
If you have pumpkin cookies, the one I make, I don't like pumpkin or pumpkin. Mr. Murphy.
The
I make chocolate cheesecake bites. Is amazing.
I've always been a fan of what is that stuff? Moose Tracks ice cream. That's kind of my. I'll have that. That's delicious. Yes, ma'am.
Have you ever? Okay, so you probably never had it, but there's like a pumpkin pie, thing from Dairy Queen, and it's got like the crust on top.
This just sounds. Pumpkin's just gross. I never liked
I
pumpkin.
tried to. My mom
Like
got
pumpkin
pumpkin,
seeds.
I tried to make her taste it. And
Kevin.
look.
Great minds think alike.
Yes,
Do
sir.
you like cupcakes?
Yeah.
My
Cupcakes.
grandma makes Snickers.
Cupcakes are disgusting.
Yeah.
Those are
Yeah. I'll have. I mean, I'm just not. I don't know.
Do you like
I'm
meatloaf?
sweet. I'm sweet enough.
What about
Yes, sir.
donuts? So yesterday I went to Maggiano's. Okay, they have like the best dessert. So
Cookies?
I got a brownie,
Why would you buy cookies?
just plain old brownie. So good with powdered sugar. And it came with like vanilla ice cream. And then my parents.
A la mode.
Yeah.
Excuse me.
And then my parents ordered like this cake. I don't even. They had like concentrate. It was so good. Do you like donuts? I don't know how to explain it.
What the heck?
How do you not like
Donuts are gross.
You like pumpkin?
I don't know, I just not, there's no easy ones.
You like steak and mashed potatoes and green beans.
Alright, so 2 questions here. They're a little bit different. One of them says, what is the measure of arc AB? The other one says the arc length of ACB. So you have to do a little bit of thinking here. Now, measure of arc AB is going to be what? 150. Everybody okay with that? Because it's your central angle. Now, if we start talking about the arc length then, what's the arc length? What do you do for the arc length?
We'll do the other.
We have to go which direction though? What's the central angle for ACB?
That's Q. Oh, that's her.
It's 210, yeah. Guys, what happens here is that it's going to ask you questions you have to reread back and forth, bless you, okay? So as you reread stuff, you have to make sure you're following which one they're asking you to do. Not always is it going to be the same problem over and over again. Sometimes you have to go the other direction. It is very, very common. So if you have a central angle of 150, on the other side is going to be how much? 210. So that just means that you're using a 210 for a central angle for the other way. So if I can move this out of the way for a second, we would have 210 over 360 times 2 times 16 times pi. Once again, I can throw all of that into my calculator, or I can simplify a few things without too much craziness. 2 is an 18, so that's an 18. These are both divisible. This becomes a 9. This is an 8. This is a 3. That's a 7. And I get 56 pi over 3.
Only my brain works like that. Cross that out.
What? If 150 is the AB, going the other direction would be 210, because how many degrees are in a circle? Don't freak out about this, guys. It's just 210 over 360. All I'm doing here is simplifying it. Right. By starting this out,
They cancel each other.
you can drop the zeros because you're dividing them both by 10.
And 16 and 36.
And then, well, 16 doesn't go into
Oh
36.
yeah, but like then you make it.
But what I can do is 2 goes into 36,
Oh, 2?
18 times. And then 18 and 16 are both divisible by 2, so it becomes 9 and an 8. 9 and 21 are both divisible by 3, so that becomes a 3 and a 7. So I'm left with 56 pi over 3.
How do you get 56? 7 times
7 times 2.
7 times 8.
8.
Where do you get the 3?
The 9 and the 21, they're both divisible by 3.
Oh. Okay, I was like, how does 9 go?
And it's, remember, I'm not going to take the calculator away from you. I just didn't have a calculator next to me, and it's quicker for me to do it this way. Sir?
Let's find A, C, another one, something,
Yeah, we can do that.
I just wrote it up that way, that's all. The other one would then be, what was it, 150? The other one would have been 150 over 360 times 2, 16, and a pi. Zeros again. And you have 40 pi over 3. Okay. And that's how that would work. All right?
Wait. Please don't go.
Once again, where's your calculator? Where's your calculator? Why not? It's a math class. You need one.
Because I just need to know how you do it this way so when I don't need a calculator.
No, wait. We don't have a calculator.
Yeah.
You need to have a calculator. Guys, if you're sitting there staring at me trying to figure out how I'm simplifying stuff, you're going to be there all day long. Bring a calculator to class so you can practice doing it the right way. Okay?
I'm just trying to learn
How many
this
years
way.
of schooling did you have?
Enough.
Oh, no, it's, okay. Wait.
No, I mean as I
I
had
like
enough
to challenge
schooling.
myself.
All right, take a couple minutes to get those arc lengths. They're looking for the arc lengths that are in red. So it's A to B, E to F, G to H. They're looking at those 3 different arc lengths. Take a few minutes and figure them out. Yes, I am. Thank you. Arc length. Central angle over 360 times 2 times the radius times pi. Zeros. This becomes a 1/6. And this becomes a 3. 8 pi over 3. Did you use your calculator? Did you get the answer? Then fine. Really?
What 2 and 2? 16.
Next one, 60. It's always nice when we have nice, easy angles to work with. 60.
Can we rewind?
Wait, I
For what?
Can we go back to the previous channel? Channel
I literally did
What do you
How
got?
did you get 160? Because I got
I got
300. Wait, what?
You're going the wrong direction. I'm using the central angle here. I'm using this one. You went the other way.
So what did I do wrong?
You didn't follow the directions.
Wait, go back up. Read the directions.
Find the length of the red arc. The red arc was AB. It's just the short one.
It wasn't the whole.
It wasn't the whole one. Every problem's different. What you did is like the example we did 2 minutes ago. You can't just remember. Everything changes. If it was 300 degrees and you got what would that have been? 300, 360, 30, or 60, 5, 6.
40 pi.
It would have worked out. You get 11 pi over 3?
40 pi over 3.
Wait, 40 pi? I don't remember what it is off the top of my head, but sure. Next one. Same deal, simplifies out. This becomes 1/6 again. This becomes a 3. You get this one, you get 11 pi over 3. Now take a look at the next question. The next one has the exact same radius as part B. They're both 11. If two circles have the same radius, wouldn't they also have the same circumference?
Yes.
Yeah. So what happens is that if you have circles with the same radius, those circles would be the same dimensions. Notice that the one angle is 60 degrees, the next one's 120. What's the difference between, how do you get from 60 to 120? You double it. So what do you think you have to do to the arc length? Double it. You get 22 pi over 3?
Oh, I didn't realize that.
That's why. If I tripled the angle, I would have gotten 33 pi over, or I would have gotten 11 pi.
So if you can recognize that, can you do it?
Absolutely, but don't worry. I mean, it's not always. That's why it's nice that I had these two next to each other. You can see that the relationship between angles, as an angle doubles, the distance that you're walking doubles because it's the same radius. That's what I think. Now, is it always this clean and straightforward? No. Sometimes you do need to work yourself backwards.
Yeah.
For example. Sometimes it's going to ask you to find portions of your, excuse me, in that formula. Like I said earlier, if you think about an arc length formula, there are 3 unknowns. The actual arc length, the central angle, and your radius, or your diameter, or your circumference. As long as you know 2 of those 3, you can always find the third. And it's just a matter of manipulating the equation by doing what amounts to being one step, okay? So in this one here, we want to find the radius of the circle. We are given the arc length on AB as 18 pi inches. Remember, arc length is a distance. Arc length will not be a degree measure, okay? It won't be a degree measure because you don't walk degrees, you walk feet, you walk inches, things like that. So if we're trying to find the radius, which of these 3 would you use to get radius by itself? The top one, because there's an R in it. So the first thing you would do is write it out. Arc length is central angle over 360 times 2 pi r. We know 2 of those 3 values. We know that the given arc length is 18 pi. We know our central angle is 90. What's that?
I didn't write
So if you think about it, you have a bunch of junk times the radius. Can't I put this much in my calculator to figure out what that value is?
Yeah.
What do you get?
You get pi.
You get pi over 2. If you type in the calculator 90 over 360 times 2 pi, it'll spit out the answer pi over 2. So now what you want to think of is that you've got the fraction pi over 2 times the radius. How do you undo multiplying by a fraction? You divide, but we don't say divide the fraction, we multiply by its reciprocal. What's the reciprocal of pi over 2?
2 over pi.
2 over pi. So you multiply both sides by 2 over pi. What's 2 times 18?
36.
What's pi divided by pi?
Pi.
What's 6 divided by 6?
0.
1.
So what's pi divided by pi?
1.
There's your radius.
You were like writing, and I was like looking down, so I didn't see how you got that 18. I know you brought it down. Why'd you put it over a 1?
What's 18 divided by 1? I just wrote it over 1 just so you can see the distinction between the 2 over pi times the 18 over 1. Because remember, when you're multiplying fractions, you're just multiplying straight across. Or throw it in your calculator. Pi over 2, or I'm sorry, 2 over pi times 18 pi, and it will simplify out to equal 36. Okay. That's how that works. Let's try another one with radius. Sometimes you'll have to deal with decimals. Sometimes you might have to worry about finding decimals as well.
Okay.
Or sorry, working with decimals, which means we have to know the correct sequences in which you press buttons on your calculator. So in this one, we have our central angle, we have our arc length. Our arc length is given to us as just 15. And it's okay that there's no pi in it, it's not a big deal. It just tells you that that distance is 15. So if you need to find the radius, again, we're going to use the top equation, the first one we talked about. The arc length is your central angle over 360 times 2 times pi times your radius. So the first thing you want to do is write that out and then fill in the blanks. Arc length is given, it's 15. Central angle is given, it's 60. Okay? So once again, in order for us to figure out what the radius is, the first thing I want you guys to do is simplify that statement first. You want to simplify that statement first. It's pi over 3, isn't it? How do you undo multiplying by a fraction? The reciprocal of pi over 3 is? So now you will wind up with a decimal. 3 times 15 is 45, and then you can divide it by pi, and you're going to get some decimal equivalent. Whenever you have to have a decimal, you always want to round it out to 2 decimal places. Psst, you've been gone for over a week. I would stop talking. Okay? When you get that, you get some sort of a decimal equivalent. What is it? 13? I was going to say like What was it?
14.32.
And that's okay that you wind up with a decimal answer. Sometimes you will get a decimal, and that's fine. If you're doing it correctly with the calculator, you will see real quick that, excuse me, that it does happen like that, all right? It does occur.
What's that?
Same deal. Let's do. It just means degrees. It's not yellow. Let's do diameter this time.
Wait, is that a? You do the second one.
Yeah, why is that an exclamation point?
We use the second one
Wait, so you use the hard one for all?
because that's what you're given. You're given an arc length.
Alright.
So if I want to find the rather than the diameter, if I want to find the diameter this time, I just start filling in the blanks. You have your arc length at 46.75. You have your central angle at 290. And it's just a matter of putting it together. Now, there's a couple of different things that you can do here. As you fill it in, it's basically, when you're multiplying a fraction together, you're just multiplying straight across. So if I take this and say that it's 290 over 360 times pi, that's the exact same thing as saying 290 pi over 360. It means the same thing, okay? Now, if I have to multiply by that reciprocal, the reciprocal of 290 pi over 360 would be 360 over 290 times pi. Are we okay with that? Now, what happens is you got to be careful when you put this in your calculator. 360 over 290 pi times the 46.75. Once again, that 46.75 is over what number? It's over 1. So all you're doing is you're multiplying straight across. In the calculator, to make this correct, you need to do this. We have to do a fraction bar. And you can type it in the numerator straight across, 360 times 46.75 over 290 pi. Whenever you have pi in the denominator with some other number, you need to make sure that you either use the fraction bar with the multi-views, or you have to group it with parentheses. Otherwise, you're going to get it wrong.
Wait, on the top bar, I can't remember. Did you plan like
Yeah.
the same way?
Mm-hmm. Yep, because that's all that means. That's all that is. That means the exact same thing as this here. Okay? It just, oops. Well, it keeps disappearing on me, but whatever. It means the exact same things. Then you hit enter, and you get them through. Let me give you a couple of problems, these real quick, because I'm running short. It's in 11.4. It's out of the book. I left my book up here, apparently.
Wait.
I apologize for running long. I'll have it posted on the calendar in a minute anyway, so. So this is page 749.
Put a P.
3 through 13, and then 15 through 23. Okay? The 11.4, obviously it's in the chapter 11 tab. I just opened it up and I know it should be all working for you guys by now as it is, okay? I'll have this put on the calendar here in a minute, but there we go. We'll continue, there's more of this we'll go through tomorrow. Quiz on memorization, units 1, 2, and art plan. Have a good one.
Don't run me over.
No, can you take a picture of her?
Oh, yes, I know. Yes, I know.
I know, I tried